Imagine our planet, Earth, a serene blue marble spinning gracefully in the void of space. It rotates steadily, a constant motion that defines our days and nights, our weather patterns, and so much more. Now, picture that motion suddenly ceasing. In an instant, the gentle, familiar spin comes to a grinding halt. Consider this thought experiment. What if Earth, currently rotating at over 1,600 kilometers per hour at the equator, were to stop its rotation in just 5 seconds? The consequences would not be merely disruptive, they would be utterly apocalyptic. Life as we know it would be erased in a maelstrom of unimaginable forces. This scenario, while purely hypothetical in such an abrupt form, allows us to explore the fundamental physics governing our planet. We can delve into the science behind Earth's rotation and understand precisely why its sudden cessation would unleash such catastrophic power. Earth's rotation is not a recent phenomenon. Our planet has been spinning continuously since its very formation billions of years ago. This persistent motion is a direct result of the processes that created our solar system. As the primordial dust and gas cloud collapsed to form the sun and planets, it began to spin. This initial spin imparted angular momentum to the forming Earth. In the absence of significant external forces to stop it, this angular momentum is conserved, keeping the planet rotating. The speed of this rotation varies depending on your latitude. At the equator, the surface is moving at approximately 1,674 km per hour, or about 1,040 miles per hour. This rotation is a fundamental driver of many Earth systems. It influences global wind patterns, ocean currents, and even the shape of the planet itself, causing a slight bulge at the equator. The principle of conservation of angular momentum dictates that Earth's rotation speed remains constant unless acted upon by an external torque. For the most part, such forces are minimal on a cosmic scale. However, Earth's rotation is not perfectly constant over vast timescales. Tidal friction, primarily caused by the gravitational pull of the Moon, exerts a small torque that is gradually slowing Earth's spin, adding milliseconds to the day over millions of years. But this natural slowing is incredibly gradual. A sudden stop, as in our thought experiment, is not something that could happen naturally. It requires an impossible, instantaneous external force. Yet, by considering this impossible event, we can isolate and understand the immense energy stored in Earth's rotation. This energy, currently harmlessly distributed across the spinning mass of the planet, would be unleashed with devastating effect if the motion were abruptly halted. Understanding the mechanics of this rotation is key to grasping the scale of the disaster that would follow its sudden cessation. It highlights the delicate balance of forces that govern our planet and make it a stable environment for life. The sheer speed of the surface at the equator, over 1,600 km per hour, represents a tremendous amount of kinetic energy. This energy is carried not just by the solid ground, but by everything on it: the oceans, the atmosphere, every building, tree, and living creature. When the ground beneath suddenly stops, everything else, by the laws of physics, attempts to continue moving at that incredible speed. This is the core principle behind the immediate, catastrophic consequences we will explore. It's a stark reminder of the power inherent in planetary motion, a power we are usually completely unaware of in our daily lives. The stability of our world relies on this constant, predictable spin. Remove that stability, and the results are unimaginable. The most immediate and devastating consequence of Earth's rotation suddenly stopping is rooted in a fundamental law of physics, Newton's first law of motion. This law, often called the law of inertia, states that an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. When the solid Earth abruptly stops, everything on its surface that is not rigidly anchored to the bedrock continues to move eastward at the speed it was previously traveling. At the equator, this means everything would suddenly be moving sideways at over 1,600 km per hour relative to the now stationary ground. This includes buildings, trees, vehicles, animals, and people. They would all be violently flung eastward. The result would be catastrophic destruction on an unprecedented scale across the entire globe, particularly in regions closer to the equator where the rotational speed is highest. Buildings would not just collapse, they would be instantly sheared from their foundations and hurled sideways, disintegrating into massive debris fields. Trees would be ripped from the ground, their roots no match for the immense inertial forces, and become deadly projectiles. The landscape would be scoured clean by the sheer force of everything moving relative to the stationary ground. Imagine the kinetic energy involved. A building weighing thousands of tons, suddenly moving at over 1,600 km per hour, possesses an incredible amount of energy. When this moving mass collides with the stationary ground or other objects, that energy is released in a cataclysmic impact. The ground itself would experience immense stress. While bedrock is anchored, the sudden deceleration would likely cause massive earthquakes and fracturing of the crust. Anything not directly fused to the planet's core would be subject to these inertial forces. This initial phase, lasting mere seconds, would transform the surface of the Earth into a chaotic, deadly environment. The sheer speed ensures that survival in the open would be impossible. Being inside a structure would offer little protection as the structure itself is torn apart. The debris generated would be flung across vast distances, creating secondary impacts and further destruction. This immediate impact is a direct consequence of the energy stored in the planet's rotation being suddenly and violently dissipated. It highlights how our everyday experience of stability is entirely dependent on the consistent motion of the ground beneath our feet. Without that consistency, the very ground becomes the source of our destruction, or rather, our inertia relative to it does. The scale of this initial devastation is difficult to fully comprehend. It's not just a strong wind or an earthquake, it's the entire world attempting to keep spinning while the ground stops. Every object becomes a projectile, every structure a fragile shell against an invisible, overwhelming force. This immediate inertial effect sets the stage for the subsequent, equally devastating consequences involving the planet's fluid layers, the oceans and the atmosphere. Following the initial inertial destruction of solid objects, the planet's oceans would unleash their own form of devastation. Like everything else on the surface, the vast bodies of water in the oceans possess tremendous inertia. When the solid Earth stops rotating, the water, not being rigidly attached, would continue its eastward motion at the original rotational speed. This would cause the oceans to surge eastward with unimaginable force and speed. The result would be the formation of mega-tsunamis, unlike anything ever recorded in natural history. These waves would not be generated by a localized event like an earthquake, they would be the entire ocean attempting to slosh over the now stationary landmasses. Estimates suggest these tsunamis could reach heights of hundreds, perhaps even thousands, of meters. Coastal cities and low-lying areas around the globe would be inundated within minutes by these colossal walls of water. The speed of the surge, matching the original rotational speed, would ensure that there would be virtually no time for escape. The sheer volume and momentum of the water would overwhelm any natural or man-made barriers. Infrastructure along coastlines, including ports, cities, and industrial areas, would be utterly destroyed. The loss of life in coastal regions, where a significant portion of the world's population resides, would be unprecedented. As the water surged inland, it would carry debris from the initial inertial destruction, adding to the destructive power. The force of the water would scour the land, reshaping coastlines and potentially extending far inland, depending on the local topography. Even areas not directly on the coast would be affected as the massive displacement of water creates chaotic and violent currents globally. The inertia of the oceans represents a colossal amount of energy. When the container, the solid Earth, stops, this energy is released as kinetic energy in the moving water. This scenario highlights the dynamic nature of Earth's fluid layers and their dependence on the planet's rotation for their stable configuration. The familiar shape of the oceans and continents is partly a result of the centrifugal force from Earth's spin, which causes the equatorial bulge. When the spin stops, this force disappears, and the water would redistribute itself, further contributing to chaotic flooding and changes in sea level. The mega-tsunamis are not just large waves, they are the entire ocean attempting to continue its journey around the globe. Their scale and speed would ensure complete devastation of coastal and many inland areas. This oceanic catastrophe would be a second wave of destruction following the initial inertial impact, leaving little chance for survival for those in affected regions. The power of the oceans, normally contained and shaped by Earth's steady spin, would be unleashed with terrifying force. It's a stark illustration of how the planet's rotation maintains the equilibrium of its surface features. Without that equilibrium, the most familiar features of our world, the oceans, become instruments of its destruction. The sheer volume of water involved means that the energy released in these tsunamis would be immense, capable of reshaping continents. This phase of the catastrophe underscores the interconnectedness of Earth's systems and how a change in one fundamental aspect, like rotation, cascades into devastating effects on others. Simultaneously with the oceanic surge, Earth's atmosphere would also react violently to the sudden stop in rotation. Like the oceans and everything else not anchored, the atmosphere is also moving with the Earth's rotation. When the solid ground and oceans abruptly stop, the air, being a fluid with inertia, would continue moving eastward at the original rotational speed. This would generate winds of unimaginable speed and power. At the equator, these winds would initially be moving at over 1,600 km per hour, well into the supersonic range. These are not just strong winds, they are faster than the speed of sound at sea level. The force exerted by winds at this speed is immense, capable of flattening virtually anything in their path. Forests would be instantly leveled, trees snapped and stripped of their branches, becoming part of the airborne debris. Any structures that survived the initial inertial impact or the tsunamis would be immediately obliterated by these supersonic winds. The entire surface of the planet, particularly in the equatorial and mid-latitude regions, would be subjected to a global sandblasting effect from wind-borne debris. The friction between the moving atmosphere and the stationary ground would generate incredible heat, potentially igniting widespread fires. The rapid movement of air would also create massive pressure differentials, leading to further atmospheric instability and violent turbulence. These supersonic winds would effectively strip the surface bare, removing soil, vegetation, and the remnants of human civilization. The atmosphere would eventually slow down due to friction with the stationary surface, but this process would take time and would involve a prolonged period of extreme weather. The initial phase, however, would be characterized by a global hurricane of unprecedented intensity and speed. Survival in such conditions would be impossible. The force of the wind alone would be instantly fatal, let alone the impact of the debris it carries. The atmospheric layer, which provides us with the air we breathe and shields us from space, would become a weapon of mass destruction. This scenario highlights the fact that even the air around us is in constant motion relative to the planet's core, a motion we only notice when it changes, like in wind. But the scale of this change, from a steady 1,600 km per hour flow to an abrupt stop of the surface beneath, is beyond anything we experience naturally. The energy contained within the moving atmosphere is also immense, though less dense than the oceans or solid objects. When this energy is released as violent wind, its destructive potential is absolute. The combination of the initial inertial impact, the mega-tsunamis, and the supersonic winds would ensure that the surface of the Earth is rendered completely uninhabitable. This final phase of immediate destruction completes the picture of a world utterly annihilated by the cessation of its fundamental motion. It underscores how the seemingly gentle rotation of our planet is a critical component of the stable environment that allows life to flourish. Without that spin, the very air we breathe turns into a force of unimaginable destruction. The thought experiment of Earth suddenly stopping its rotation, while physically impossible in its abruptness, serves as a powerful illustration of the fundamental forces and energies at play on our planet. It reveals the delicate balance that sustains our world and the catastrophic consequences that would ensue if that balance was suddenly and violently disrupted. If you found this exploration fascinating, please like, share, and subscribe our channel, The Turkish Odyssey, for history, culture, food, or simply curiosity. Have questions or topics you'd like us to cover? Leave a comment below. Thank you very much for your support.